Hello and welcome, and in this video we're going to actually be talking about graphing linear equations, so a really important topic for Algebra 1 and Algebra 2. And when we're talking about graphing linear equations, there's actually three forms of a linear equation. So, three forms of a linear equation. There is standard form, which is ax plus by equals c, where a, b, and c are just numbers like 2, 3.5, 2.718, whatever. So that is standard form. We have point slope form, which actually gives us a point and the slope of the line. The point is this x1 and y1 here, and the slope is m. And then there's slope-intercept form, which is probably the most widely used and most widely taught of the three forms. So slope-intercept form, and that's actually the one we're going to be focusing on today as well. So I'm going to get these other two out of here. Okay, now slope-intercept form. The reason it's called slope-intercept form is because it actually gives you the slope and the y-intercept, because mathematicians are not creative in names. So we have the slope, and the slope is represented by this letter m. And in an actual equation, it's going to be a number like 2 or 1/3 or -5/4 or something like that. And the slope is what we refer to as the rise over run. Okay, and what I mean by that is the numerator of that number is going to tell us how high we're going up or how low we're falling. And the denominator of that number is going to tell us how far over to the right we will be going. Okay, so a lot of people refer to it as rise over run, change in y over change in x, etc., etc. Where b is the y-intercept of the line. Okay, so like I said, very original naming because it gives us a slope and the y-intercept. So let's take a look at an example here. So I have y equals 2/3 x plus 1. Now I'm going to walk us through this. Now in slope-intercept form, the number that is multiplying x is the slope. So this 2/3 here, right here, this 2/3 is the slope. Okay, and slope is rise over run. So this 2 represents the rise. So we will be going up 2, and the denominator is the run. So we will be going to the right 3. So the numerator is 2. That means we're going to be going up 2, and the denominator 3, which means we're going to be going to the right 3. And this number that is adding to x, which in this case is 1, is our y-intercept. So that means that the y-intercept for this particular line is the point 0, 1. Now, when we're graphing using slope-intercept form, we want to start at the y-intercept. So I'm going to go ahead and plot that y-intercept right on the graph here, okay? And now we're going to be using the slope to actually find the rest of the points to this line. So we're going up 2 and right 3. So I'm going to go up 2 and right 3. And from there, I'm going to go up another 2 and right 3. And we can kind of just keep doing this until we run out of room. Okay, and that will be a bunch of points on a line, but we can actually go backwards as well. So we are going up 2 into the right 3, and if I kind of wanted to go backwards so I can get some points on this side, I would be doing the opposite. I would be going down 2 and left 3, down 2 and left 3, and down 2 and left 3, okay? And now that we have all these points, we can go ahead and connect them to make our line. Okay, so there is our line. And now a lot of times teachers will just be like, hey, graph this line, but there is a reason that we're graphing these lines. There's a reason why we graph anything that we graph, okay? And that's because a graph is a visual representation of all the solutions to an equation. And that might seem like a mouthful, but it's really actually fairly straightforward. Every single point on this line here, if we were to grab the x and the y for that point and plugged it into this equation, it would work. Okay, so why don't we go ahead and I'll just show you real quick with one of these particular points. So let's say I grab this point right here. Oops, I grabbed that in white. Probably shouldn't have used white for that. Let's say I grab this point right here That point was 0, 1. If I plug that point into this equation, it's going to end up working. So the point was 0, 1, so y was 1. So I'm just going to plug in the y and the x. So y was 1 equals 2/3 times x, which is 0 at that point, plus 1. So I just plugged in the x and the y into this equation here, okay? And now if I went ahead and kind of simplified this, it would be 1 equals 2/3 times 0 is 0. 0 plus 1 is 1. So notice it ended up working. 1 equals 1. That's what I mean by every point on the line is a solution to the equation. So if I plugged any of these points in, they would all work. So that's actually why we graph any equation that we graph. I know it's not mentioned a lot, but it is really important to understand why we graph what we graph, all right? But that's one example. Let's take a look at another example. Okay, so we have a different example here. We have y equals -5/2 x plus 3. So remember, we are graphing using slope-intercept form, which means we need the slope and the y-intercept, and it's as easy as picking the pieces out. Okay, so the slope, remember, is m. It's whatever's multiplying x, which in this case is -5/2. Now, remember, slope is rise over run, and now since this is negative here, that negative means instead of going up, we're actually going down. So we will be going down 5 and right 2, okay? So the numerator, whether it's positive or negative, tells us if we go up or down. The denominator is just how many we're going to the right, always to the right, okay? The negative just tells us if we're going up or down. Okay, so that is our slope, -5/2, but we need to know what our y-intercept is, which is 3 in this case, which tells us that the y-intercept is the point 0, 3. Okay, and that's where we need to start. So I'm going to plot 0, 3 on my graph right here. Okay, and now I'm going to use this slope. Down 5 and right 2. So I'm going to go down 1, 2, 3, 4, 5, right 2. There's my next point. Okay, and I can do that again. And I kind of run out of room that way, but I could also go backwards. So instead of going down 5 and right 2, I can go up 5 and left 2 to get some more points. And that's really the only other point I can plot. If you had a bigger graph, you can do more, obviously. But this is enough. Normally about 3 or 4 points is more than enough. And now we're going to go ahead and connect that. Try to get all the points on yours. It's a little bit hard to draw on this tablet to get through all of them, but that is our line, okay? So that is the line for the equation y equals -5/2 x plus 3, okay? Now, both of these were in slope-intercept form already. Now, I did show you those other two forms, standard form and point slope form, and although you could graph from those forms as they are, it's nicer to get them in slope-intercept form and to graph them that way. So let's go ahead and take a look at an example of something like that. Okay, so now we have a different example, and notice this is not in slope-intercept form yet. This is in standard form. 8x minus 2y is equal to 12. Now, what we want to do is first get this in slope-intercept form, and it's in slope-intercept form if it's solved for y. So I'm going to solve for y, and then that means it's in slope-intercept form. So to solve for y, I want to move everything that is not y onto the other side of the equation. So I'm going to subtract 8x from each side. I'm going to subtract 8x from each side, so that's going to become, well, those cancel. -2y is equal to, now these are not like terms, so I can't combine them, so you can have it as 12 minus 8x, but I'm going to rearrange it to kind of fit our format a little bit more, okay? So I'm having x come first. Still the exact same equation, okay? So -2y is equal to -8x plus 12, and slope-intercept form means y is solved for, and I still have that -2 there. Now, -2 is multiplying y, so I can go ahead and divide each side by -2 to get y isolated. So that's exactly what I'm going to do. So that's going to become y, the -2's canceled, they divide, make it 1y, which is just y, is equal to, now everything gets divided by -2, so that's going to become 4x, -8 divided by -2 is +4, 12 divided by -2 is -6. So here is our equation. Notice now y is by itself, so that's slope-intercept form. So I now have it in a slope-intercept form, which means I can figure out my slope, which in this case is just 4. Now, you can think about that as 4 over 1. That's the same thing, right? 4 over 1 is 4. And that might help some of us that rely on that denominator. If it's just a number like 4 or -2 or 16, it's over 1, okay? But if you want to put it over 1 to kind of really visualize it, feel free to. It's the same thing. So since it's positive, that means it's moving up and it's going up 4. And since the denominator is just 1, that means it's going to the right 1, okay? And the y-intercept is not 6, it's -6, sorry, which means that the y-intercept is the point 0, -6. Okay, so that's where I'm going to start. I'm going to plot 0, -6, and now I'm going to use my slope, which is up 4, right 1. So this is going to rise really quick. So up 4, right 1, up 4, right 1, up 4, right 1, and up 4, right 1, and I can go backwards. And there I go. And notice I got plenty of points here. So now I can go ahead and connect this to make a nice line. Okay, so that is graphing when it's not in slope-intercept form right away. That was from standard form. It can be really in any form. Let's go ahead and take a look at an example where it's actually already in point slope form and we can get it in the slope-intercept form. All right, so this is an equation in point slope form. We have y minus 3 is equal to 1/3 times the quantity of x plus 6. So we want to isolate y. We want to get this in slope-intercept form. So the first thing I would do is distribute the 1/3 into that quantity, okay? So this is going to become y minus 3 is equal to 1/3 x, 1/3 x plus, now 6 times 1/3 is 2, so plus 2. And now all I need to do is add 3 to each side and combine it with its like term. You can't combine it with 1/3 x, right, guys? I need to make sure that we know that, okay? They're not like terms, so 1/3 x is going to stay the same, and I'm going to have plus 5. So y is equal to 1/3 x plus 5. So that tells us that the slope is 1/3, so we're going up 1 and right 3, and that the y-intercept is 5, so it's the point 0, 5, and that's where we're going to start. 0, 5, bam, it's plotted. Now we can use our slope. So up 1, right 3, up 1, right 3, up 1, right 3. I ran out of room. I can go backwards if I want to, doing the opposite. Down 1, left 3, down 1, left 3, down 1, left 3. So there's a bunch of points. Let's go ahead and connect them. And here we go, bam. One side, the other side. And that is our line. And that's graphing linear equations. It's really not too bad, guys. If you're an Algebra 1 student and seeing this for the first time, don't stress. It really doesn't get any more complicated than this. But if you have any questions, please feel free to let me know. I hope this video was helpful. And in the next couple of videos, we'll be graphing linear inequalities and also talking about systems of linear equations and inequalities and graphing multiple lines in the exact same coordinate plane. It's actually pretty cool. So I look forward to seeing you in that next video.